All right, we have another coding exercise. Find the index of the first occurrence in a string. And what we want to do is we want to find the index of the first occurrence in a string. It's pretty straightforward. Yeah, we just want to find a substring within a string, find the first index where it exists. All right, so the way that we can go about doing this, one solution, and again, I am going to be handwriting code. This is unusual, but it helps me think, and it's what I want to do, so it's what we're going to do. So one thing that we could do here is we could return haystack.find needle. Right. How does this work when we try it out? Return haystack.find needle. Let's try it out. And there we go, it works. So thank you for watching. No. Okay, so this seems a little cheap because there's just a function in Python that lets you do this. But yeah, so basically this find function, it does literally exactly what the question is asking for. It will try to find the whatever's in here, needle. It'll try to find that within this string haystack, and if it finds it, it will return the first index where it occurs. If it doesn't find it, then it's just going to return -1. Which is exactly what the problem wanted us to do. So yeah, Python actually has a built-in function for this, but this seems, let's do like a real example of how we would actually code this if this function didn't exist. So basically what you could do is you could loop through the indices in haystack and see if it's a match with needle. So, and so what indices are we going to want to loop through? We're going to want to start with 0, obviously, and we're going to want to go up to, we only need to go until the, maximum possible index, which would be, let's see here. Let me actually write this out. So so if you think about this, if you have let's just look at an example. If needle is AB and haystack equals C AB, then you only need to, in this example, you only need to look up to the first index, because then the length of needle will take you to the very end of haystack. And so let's see here, the very last index that you need to check is index 1, because it's C is index 0, A is index 1, and 1 is going to be the length of haystack minus the length of needle. So if we're actually going to start our code, the last possible index, or I'll just call it the max index, is going to be the length of haystack minus the length of needle. And for this exercise, one thing we can do, with this being a more straightforward exercise, let's just use this as an opportunity to recall, because we're going to be working with indices and lengths and stuff. I want to take a moment to recall how they work. So the length of x is the number of characters in x. And now when we're looping through the range, because that's the next thing we want to do, range of n includes integers, numbers, but I'll call it integers to be more specific, from 0 to n minus 1. So range of n doesn't include the actual number n, it only goes up to n minus 1. Then finally, if we have a string s, then s n through m returns indices n to m minus 1. So again, we have this sort of like, basically the reason that I'm writing this thing out is that there's a lot of opportunities for off by 1 errors here and for confusion here. And so it's useful to like keep track of this mentally when working on problems like this. Okay, so we want to loop through every possible index that could be the start of needle. And so obviously we want to start at 0 because that's the first possible index. And the last possible index would be the length of haystack minus the length of needle, because we can see in this example, the last place it could occur would be index 1, which is 3 minus 2. Okay, so for I in range max index. Now remember, when we're looping through here, we want to check if this index I is the starting index for the string needle within the string haystack. And max index is the last possible index that I can start. So we want to include this max index in our loop. And range of n only goes up to n minus 1. So here we need to add 1 to our range. And then we just check if needle, basically what we want to check is if needle is the substring of haystack with the same length of needle starting at index I. So we're going to write that out. So if needle equals haystack, we want to start at index I, and where do we want to go up to? So let's see here. We need the ending index to be, so let's say as an example here. So needle is AB, so there's 2 values here. For here, haystack, we would want to check just when I equals 0, just to start out with, we want to check for index 0 and index 1. So we want the final index in the substring to be 1. And so we want the final number that appears here to be 1 plus 1, which is 2. And this is just the length of needle. So from I up to I plus the length of needle. Right, because if you think about the integers from I up to I plus length of needle, there's going to be length of needle plus 1 integers in that sequence. And we only want the first length needle of them. And so we want to make sure that the index we go up to is actually I plus length of needle minus 1. And so that's exactly what this does. All right, and then if it's a match, then we return that index. And then if we go through this entire loop and we don't find the needle, then we're just going to return minus 1. Okay. By the way, something that came up in one of the test cases. It's worth considering what would happen if the so here we have ranges for the lengths of haystack and needle. We actually need to think about what would happen if the needle were larger than the haystack, if the length of needle was larger than the length of haystack, which is not something you would think about in this problem, but given the constraints, it is a possibility. But if you look at this, if the length of needle is greater than the length of haystack, max index is going to be negative. And so this loop is just not going to occur at all. So it's just going to skip over this loop and return -1, which is exactly what we want. And I guess the only other thing to note is that when I was explaining about haystack here, that sort of shows why keeping in mind all these facts about how these things work is useful for explaining everything and keeping everything track in your head and making sure that you're not getting off by 1 errors. Okay, so this is the code, so we can just go back and let's actually just refresh it and make sure that this works. So max index equals length of haystack minus the length of needle. Then we're going to loop through all these indices. We need to add 1 there. So if the needle is equal to haystack, we start at I and we go up to I plus length needle, then we return I. At the end of that, if we haven't found it, we return -1. Let's just check that this works and make sure I didn't make any typos or anything. And there we go. Okay, so this is, if you didn't want to just use the 1-line function that's built into Python, you could just do this. And you could think about if there are potential ways to optimize this, like we're including length of needle a bunch of times here. So I guess it would make sense to save it to a variable first and then like just reuse that variable a bunch. You can also think about instead of like getting haystack I through I plus length needle every single time, you could just like define a subset and then with each iteration you remove the first character in the string and then add on the next character in haystack to it. But in any case, like this is a pretty straightforward problem. So we can just sort of keep it here and then move on to other problems. So there we go.